Good evening, all of you.
Good evening, sir.
Good evening,
Good
sir.
evening, sir.
Good evening.
Good evening, sir.
Yeah. I believe, don't type to the co-host. Mahendra Chaudhary, you type it to the co-host, I'll not be able to read that. Host is what I'll be able to read. But wait. I have 3 batches here. 2 from Dadar, 1 from Andheri. Am I right? Sorry, 2 from Andheri, 1 from Dadar. Dadar students say hi.
Sir, what do you want, sir? The other.
Hi, sir.
Okay. And Andheri, old APJC 2 and old APJC 3.
Yes, sir.
Yes, sir.
Fine. Today we are discussing booklet exercise 1, 2, 3, 4 of gravitation. Is the instruction very clear?
Yes, sir.
Yes, sir.
Gravitation booklet exercise 1. Bolo.
So question 5, 9, 14, 5, 9, 14, 23,
Sir, 12.
29, and 33.
Here 12.
8, sir, 8.
33.
33.
24.
26. 26.
7.
Sir, 31, 32, 35.
एक के बाद एक नंबर बोलो मैडम.
41.
41.
Sir, 3, 3, 3, 1.
What is she saying?
31.
31.
31.
Okay. Fifth question is a small cheap trick plate. There is one mass here, one mass here. Center of mass of these both will come here, COM. Do you agree with that?
Yes, sir.
Yes, sir.
Gravitational force on
Yes,
this
sir.
is 0. What is G at the center? 0. There will be only mg force on this. Mg on this is 0. As a result of which, center of gravity will lie on this point. Center of mass will lie at this particular point. Here G is 0. So there is only one particle. Gravitational force will act on that particle. Center of gravity is that particular point.
Sir, center of gravity का definition क्या?
Where the gravitational force acts. If n number of forces are acting, acceleration of that point will be center of mass where all the forces appear to act. Where gravitational force appear to act. When will that be different? Center of mass and center of gravity are at the same place. When will that be different? When you have Earth like this and a thin rod standing this way. G value here are different. So center of gravity for whole of that will not act at its center of mass.
Sir, but we are not taking the gravitational force by the second mass on the first mass.
Nine. They are point masses. They will give negligible force at 6,400 kilometers. Now, seventh question. This point is at a distance of 3r. So, if I take the total mass capital M, F1 will be G capital M, small m by 3r whole square. As simple as F1, right? What will F2 be equal to? F2 will be field because of the complete sphere Gm by 3r whole square minus field because of the removed sphere M0. Removed sphere M0. G M0 by distance from here is 3r. This is r by 2. This will be 2.5r. 2.5r whole square. Substitute M0 and that into M will be F2. How do you want me to substitute M0? M0 will be capital M per unit volume 4 by 3 pi r cube into 4 by 3 pi r by 2 whole cube. Unitary method. So F1 and F2, after substituting M0, divide both, you get the answer. Mass and diameter of a planet are twice that of Earth. What will be the period of oscillation of a pendulum on this planet if it is a second pendulum on Earth? Only problem which you will have is time period is 2 pi under root L by G. G is Gm by R square. Now he is telling you mass and diameter of the planet are twice that of Earth. T dash will be 2 pi under root L by G dash. G dash is 2m by 2r whole square. Now substitute this G dash here, this G here. Only doubt that you will get is how much is T? Second pendulum time is 2 seconds. Second pendulum time is 2 seconds. That is the only doubt that you will have. Take it down till here. I will have to rub the board.
Sir, can you also put 20, 21, and 27 and 30?
When I come to 20, tell me, I'll take it up.
Yes.
Tell me when I can rub the board.
Yes, sir.
Yes, sir.
No. Question number 9. 9. Particle of mass m is at a distance a from the surface of a thin spherical shell of equal mass and having radius a. Okay, gravitational field and potential both are zero at the center of the shell. Gravitational field. Hey, listen, when you have a shell like this at the center, because of the shell, the field is zero. Not because of this capital M. This will give me non-zero field here. Because of capital M, the field is zero. Because of this capital M, the field here will not be zero. Because of capital M, potential is constant. Because of this capital M, why will the potential here be constant? It will depend on distance.
Okay, sir.
Well,
Sir, can you show the 10th one?
Yeah, so the 10th one, please.
10th one, 3 particles are going in a circular path this way. On this, I'll call this force of attraction. I'll call this force of attraction. Can you calculate that force?
Yes.
if I resolve those forces towards the center, 2F cos theta will provide the required centripetal force.
Okay, sir.
12. Satellite revolves in a geostationary orbit, but in the direction of east to west. Time interval between successive passings about a point on the equator. Earth is rotating in which direction?
West.
Earth rotates west to east.
Earth is rotating from west to east. Earth is rotating in this direction. And the satellite is moving in opposite direction with the same time period of 24 hours. What makes you say that it is 24 hours? Because it is a geostationary satellite. So if this is rotating this way and the satellite going in opposite direction, both with equal speed, equal time periods, that means both have the same omega. You get the point? This is rotating in one direction, the satellite is going in opposite direction with the same omega. When will it come back to the same point? If this is at rest, it takes 24 hours to come. But by the time this turned by 180 degree, this will also turn by 180 degree. Earth also rotates by 180 degree. So after every 12 hours, the satellite will be above that particular point. Is that 12th question clear?
Yes, sir.
14. Spherical uniform planet is rotating about its axis. Velocity of the point at its equator is v. Now, G phi is G minus R omega square. At the equator, due to its rotation, this is the formula. Did I derive this for you?
Yes, sir.
G by 2 is G minus R. Omega is V by R whole square. Right? V square by R is G by 2. V is root over of GR by 2. Now escape velocity V is root over of 2GR. Divide both, you get the relation between them. Tell me when I can rub the board.
Yes, sir.
Sir, can you do question 15?
Okay. Question number 15. Two point masses of masses 4m and m respectively separated by a distance d are revolving under mutual force of attraction. Ratio of their kinetic energies. This will be 4m and this will be m. Going about their common center of mass. Am I right? No. Are separated by a distance of d. Are separated by a distance of d. 4m and m. Distance is d. Revolving under mutual force of attraction. Revolving under mutual force of attraction should be about their common center of mass. What I drew first is right. This is 4m. This is m. I take this to be R1 and this to be R2. R1 plus R2 you have given is D. 4m into R1 is m into R2. 4R1 is equal to R. Right? Now, can I get R1, R2 in terms of D? Substitute R2 here. 5 R1 is D, R1 is D by 5. Will I get R2? R2 is how much? 4D by 5. Is this information clear? Say here, is it clear?
Yes, sir.
Now, Gm1 M2 by G4M into M by D square will provide the required centripetal force M omega square R2. The same force will provide centripetal force for M omega square R1. Omega of both should be the same. Binary star system. Did I cover in your class?
Yes, sir.
Yes, sir.
Now, the omega will be the same for both. So he is asking you the kinetic energy of the particle half I omega square. I will be 4m into r1 square. This is one kinetic energy. Kinetic energy of the other will be half I omega square. I will be m into r2 square. Their point objects. Kinetic energy of one particle is half I omega square. I is 4m into r1 square. The other kinetic energy is half mr2 square. I will be mr2 square. That was question number 15. Somebody asked question number 21. Am I right?
And 20, so
21 may, I'll tell you where you are going wrong. You are missing the negative sign in front of the expression for potential. Take the negative sign into consideration, you will get the correct answer. एक बार अभी 21st का क्वेश्चन पढ़ लो. समझ में आया कि नहीं? 21st
yes,
का
sir.
आया. You are missing
Yes,
the
sir.
negative sign. You will not get the answer because you forget the negative sign in front of potential. The question is mainly given for that. 20th. Suppose a smooth tunnel is dug along a straight line passing through 2 points on the surface of Earth and a particle is dropped from rest at its one end. Uniformly distributed particle is emerged from the other end with the velocity. Particle will come to rest at the center of the tunnel. Because of this position, particle is closest to the Earth's center. Dug along a straight line joining 2 points on the surface of the Earth. Particle is dropped. Potential energy of the particle will be equal to 0 at the center of the tunnel as it is along the diameter. Acceleration of the particle will be proportional to its distance from the midpoint of the tunnel. 20th May, which option do you have it up? If you dig a tunnel this way, you drop a body here. Why will it come out with velocity here? If velocity here is 0, this will also be 0. First bit mein he is saying it, you drop a body at one end, particle is dropped at one end, and it will emerge from the other side with the velocity. If the velocity is 0 here, velocity will be 0. Center of the tunnel, remember potential is not 0. Who told you potential is 0 here? V is minus Gm by 2r cube into 3r square minus 0 square. At the center, small r is 0. Field is 0 at the center. Small g is 0 at the center. Potential, no. Remember this expression. That into small m is the potential energy. Acceleration of the particle will be proportional to its distance from the center of the tunnel, quite obviously. We proved that for SHM, A is directly proportional to X. We dealt with this SHM in the class, yes or no?
Yes, sir.
Now
Yes,
is
sir.
20th clear?
86 wala.
So in the 21st one, I wanted to just confirm if I did the right thing. So we know that the mass will be the same. So I wrote m1 is equal to m2. And for potential, gm2 upon r2 upon gm1 upon r1, I found the ratio. we can cancel M1 and G, and we know the relation between R1 and R2. So I get 1/2. From that, you can see that it reduces.
अभी 21st का मैंने कुछ बोला है, आपने सुना है?
So the negative might be missing. But so it gets cancelled out, right?
Hollow spherical shell is compressed to half its radius. 21st. Potential is minus Gm by R. If radius decreases, you are under the assumption that this increases. But the fact being, because of the negative sign, the potential decreases. इतनी सी बात.
Yeah,
If
so
radius decreases, we are under the impression that potential increases. But with the negative sign, the potential decreases. Why do you make the problem big? Somebody typed, I don't think binary star system was done in old APJC2. Will somebody confirm this to me, please?
So we were not. हमको भी नहीं करा था, मैं OPJC 2 में नहीं करा है.
Binary star नहीं हुआ?
कराया
नहीं,
है
sir.
सर.
क्लास नोट्स तो देख लो. बाय चांस अगर if old APGC2 में नहीं हुआ, the next class when I come to the class, can you remind me first that binary star is not done? It takes 5 to 10 minutes. I'll cover it, but it should be done.
सर एक क्वेश्चन था, उतना ही है क्या? एक क्वेश्चन कराया था आपने.
Binary star system का एक ही सब टॉपिक है. Two stars going around their common center of mass. We calculated angular momentum and kinetic energy. हाँ या ना? Half mu omega square r square. अगर नोट्स देख के हाँ या ना बोलने में इतना टाइम लगता है यार. नोट्स है आपके पास? Can I have the board?
Sir, can you do question 22?
Coming to that. By chance, if I have not done binary star, next class will, as soon as I come, please remind me once. Question number 22 may find out initial potential energy, final potential energy. Difference is the answer. 22 may you have two triangles, right?
Yes, sir.
Yes.
He's asking you how will you change the configuration from one to other. Can you find out the initial potential energy? 22 initial potential energy. He gave some masses here. This is given as 3m. This is given as m. This is given as 2m. A root 2. What is the initial potential energy? Minus g 3m into m divided by a. Minus g m into 2m divided by a. Minus g 3m into 2m divided by a root. Similarly, can I find out u final for the triangle given? Difference will be the work done. Say something. Will you be able to complete that?
Yes, sir.
Yes.
23. Two satellites of masses M1 and M2 are in the same circular orbit around Earth but revolve in opposite ends. When they undergo completely inelastic collision, the combination will go in an elliptical orbit. This is a inelastic collision जब करते हो तो energy decreases. Yes or no?
Yes, sir.
Energy अगर decrease हुआ तो it cannot go to an outer orbit. It will have to come into an inner orbit. Now you cannot tell me it will come like this and change its orbit. Who will do the changing of this orbit? Somebody should change the direction. Here on Earth, it is very easy for me to change my direction because I've got friction as external force. वहां कौन सा external force है आप पर? So changing the direction is not easy. Rather, you should have a rocket propulsion for that. So what happens is this will go in this particular elliptical orbit. Energy decreases, goes in an elliptical orbit within the original circuit. 24. Particle is dropped on Earth from a height r and it bounces back to a height of r by 2. Coefficient of restitution for collision is small e is equal to v by u. Now on Earth, it is dropped from a height of r. This is r. It is dropped from a height of r. That means what will be the velocity u? Minus g capital M small m by 2r plus initial kinetic energy is 0. Final kinetic energy is half m u square minus g capital M small m by r. On the surface, this will be the potential energy. Will I get u from here? This u I will substitute here. Similarly, find out v. It is rising up with a velocity v. Right? Initial potential energy on the surface is g capital M small m by r plus kinetic energy is half mv square. It will go to a height of capital M small m by r by 2. Plus here kinetic energy is 0. When it goes to the maximum height of r
3r
by
by 2, right?
Pardon?
3r by 2, right?
3r. From the surface, if it goes to r by 2, from the center it will be 3r by 2. Now this velocity v I will substitute here. I get the coefficient of restitution. I will have to rub the board. I'll give you 2 minutes for this.
So can you explain 23rd again?
23rd May, according to you, among the 4 options, which option do you think could be your doubt?
Sir, A wala.
What does the A wala say? A wala says continues in the same orbit. You really think that is feasible when the energy decreases? They are going for an inelastic collision. So some energy is lost. Energy decreases. How will it continue in the same orbit? Okay.
Sir, then B भी हो सकता है ना? Circular orbit of lesser radius.
That's what I asked you. You will bring it here, turn it and project it in that radius. Who will do the turning? पूछो. Lesser radius के लिए after collision, how will it fall in that orbit? Tangentially it should enter, right?
Yes, sir.
नीचे आएगा, फिर टर्न कौन करेगा? सुपरमैन, शक्तिमान या बैटमैन? टर्न तो किसी को करना है,
So,
right? Can I rub the board?
Yes, sir.
Sir, what does it mean by within the same circle?
Within the same circle, inside the circle, is the circle, within the same circle, is the circle, within the same circle. inside.
Okay, sir.
Now question number 26. Two satellites S1 and S2 describe circular orbit of radius R2 are respectively around the planet. The angular velocity of not fair. 26. T square is directly proportional to R cube. T square directly proportional to R cube. T is 2 pi by omega. Whole square directly proportional to R cube. Divide. रेशियो को एक ओमेगा दिया है, दूसरा ओमेगा पूछ रहा है. $29. Listen to 29. 5m is moving with a velocity u. At one point in its orbit, satellite explodes into two pieces, one of mass m and the other of mass 4m. After the explosion, mass m ends up traveling in the same circular orbit but in opposite direction. Mass m, 4m. M will go back with the same speed. M will go back with the same speed. How do you know that M goes back with the same speed?
Same orbit.
Same orbit. So conserve linear momentum. 5m into u will be equal to m into minus u plus 4m into v. So v will be equal to 6u. Calculate u and substitute, you will realize that v is greater than the escape velocity.
Sir, it's V 6u by 4.
6u by 4. Now this turns out to be greater than root 2 times u.
Yes, sir.
A root 2 times u से आपको क्या लेना देना है? Why do you have the fancy for this? If u is the orbital velocity, escape velocity will be root 2 times the orbital velocity.
Yes, sir.
So 6 by 4 is greater than root 2. So that means 4m acquired a velocity greater than.
Escape velocity.
It will escape from Earth's gravity. It will not be in a bound orbit. It will
Yes,
be
sir.
in an unbound orbit. In that question, there was an unnecessary confusion created by this word partially bound orbit. There is nothing called partially bound orbit. It's either bound or unbound. Bound orbit energy should be negative. Unbound orbit energy should be positive. Very clear with that?
So by partial orbit, did they mean elliptical orbits?
That's what probably they tried to say, but such a thing don't exist. Right?
Sir, 30.
Pardon?
Sir, the 30th question. Three zero. Planet of mass m 30. Planet of mass m is in the elliptical orbit about the sun with an orbital period of t. If a is the area of the planet, then its angular momentum is. Second law of Kepler's law is this, right? dA by dt is L by 12. We derived this. So angular momentum पूछ रहा है. L is 2m A by T. Oh. A satellite is orbiting around the Earth in a particular orbit. Its time period is t and orbital velocity is v. In another orbit, the orbital speed is 2v. Then the time period v is root over of gm by r, orbital velocity. Right? In another orbit, orbital speed is 2v. Now see, time period is 2 pi r by v. V I will put as under root gm by, keep it as v. He wants relation between t and v, no, yeah. orbiting around the Earth. In a particular orbit's time period is t, and the orbital speed is v. In another orbit, the orbital speed is 2v. New time period puts right. 2 pi r dash is 2v. Now divide both, you should get the answer provided you know the relation between r and r dash. How do you get that? V is this. 2v is root over of gm by r dash. Divide these both, you get the relation between r and r dash. Divide these both, you get your answer.
So, what I did was I used the relation t square directly proportional to r cube and v naught square directly inversely proportional to 1 by r. उससे भी चलेगा ना?
It will again beating around the bush, you'll have to come here. It's the same thing, however you want to solve. But a simple straight it is, you can divide any way you want.
Sir, can you do question 32?
32 once again binary star. कौन सा section से हो आप? APJC 2.
No, sir, 3. I solved, but like beach mein I don't know.
Omega 32 में G capital M small m by r square will be m omega square r. Find out omega. 2 pi by t. Time period is 2 pi by omega. Binary star system में the two stars, I am taking this as capital M, this as small m. The distance between them I am taking as r, r1 and r2. Right? M omega square r2. Find out omega 2 pi by t is your answer. Time period of each star. Both the stars will have the same time period because both the stars have the same omega. Tell me when I can rub the board.
Yes, sir.
Thirty-three. Spaceship of mass m is in circular orbit of radius 2 Ra about the Earth of mass capital M and radius r. Spaceship of mass m is in circular orbit of radius 2 Re about Earth of mass capital M and radius. Energy required to transfer the spaceship to a circular orbit of radius 2 3 Re. Total mechanical energy, can you calculate? How will you calculate?
So minus gmm upon 2r.
Now एक बार r के प्लेस में 2 Re डालोगे, दूसरी बार 3 Re डालोगे. Difference is the work done. Conservative field में if I am moving something from one orbit to the other orbit, total mechanical energy in one orbit minus total mechanical energy in the other orbit is the work done. Yes. What's the below?
Yes, sir. बट सर फिर मैकेनिकल एनर्जी में इधर काइनेटिक एनर्जी भी लेंगे ना.
दोनों लेके ऐड करने से ही टोटल मैकेनिकल एनर्जी आता है. देख लो क्लास नोट्स एक बार खोल के. काइनेटिक एनर्जी, पोटेंशियल एनर्जी ऐड करने से टोटल मैकेनिकल एनर्जी will be minus g capital M small m by.
उसमें सर वो तो हाँ वो देखा, उसमें v को सब्स्टिट्यूट क्या करेंगे?
v कहाँ पर है?
काइनेटिक एनर्जी में हाफ mv स्क्वायर लेके v में क्या सब्स्टिट्यूट करेंगे?
भाई साहब नोट्स है आपके पास?
हाँ है.
एक बार टोटल मैकेनिकल एनर्जी जहां कैलकुलेट किया वहां पर जाओ.
टोटल मैकेनिकल एनर्जी में v है ही नहीं। v ऑर्बिटल वेलोसिटी सब्स्टिट्यूट करने के बाद आपको टोटल मैकेनिकल एनर्जी माइनस g कैपिटल M स्मॉल m बाई 2r आता है। एक्सप्रेशन तो देखो, नोट्स तो खोलो कभी ना कभी। टोटल मैकेनिकल एनर्जी जहां पर लिखा हुआ है केप्लर्स लॉस के जस्ट पहले होगा क्लास नोट्स में। एक्सप्रेशन फॉर टोटल मैकेनिकल एनर्जी देखो, दिस इज सुसाइडल। एट दिस स्टेज यू आस्क मी हाउ यू गॉट टोटल मैकेनिकल एनर्जी पूरा ग्रेविटेशन होने के बाद। कर क्या रहे हो आप क्लास में? हाफ m ऑर्बिटल वेलोसिटी इज रूट ओवर ऑफ gm by r whole square minus g capital M small m by r. This is potential energy, this is kinetic energy. G capital M small m by 2r minus G capital M small m by r. Half minus 1 is minus half. G capital M small m by 2r. Didn't we deal with this?
Yes, sir.
How can you afford to forget the expression for total mechanical energy? बोर्स एटॉमिक मॉडल में भी किया हुआ है आपने। माइनस के कैपिटल क्यू स्मॉल क्यू बाई 2r। माइनस 13.6 इलेक्ट्रॉन वोल्ट्स कहां से आया आपको? यहीं से तो आया हुआ है। केमिस्ट्री में पढ़ा है, ग्रेविटेशन में पढ़ा है, अब फिर भूल जाते हो। नॉट एक्सेप्टेबल। Exercise 2.
2, 3.
So
Sir,
question
number
1.
5.
Sir, question 3.
3.
2 and 3.
5 सुना है मैंने।
हाँ सर
Sir,
5 है।
So
Six.
So
second.
6.
6 and 10.
9.
So second.
So 8.
ये बाकी क्या बचा यार? इसमें 4 एक नंबर बचा है। उल्लू बना रहे हो आप लोग मेरा। 4 भी क्यों जोड़ दिया? वो भी पूछ लेना था।
Sir, even 7 is remaining.
हाँ, smart answer. 1. Assume the Earth to be a sphere of uniform density, then acceleration due to gravity at a points outside the sphere is inversely proportional to the square of the distance from the center. True. At a point outside the Earth is inversely proportional to the distance from the center. Wrong. At a point inside is 0. Wrong. At a point inside. ये first question कौन सा bit में doubt है आपको?
So can you explain the D option?
D option. At a point inside it is proportional to its distance from the center. What is the field at a distance of small r? Field in a solid sphere. This was G capital M small r by capital R. Yes or no?
Yes.
Field is nothing but G. Yes or no? ME is the force, MG is the force, G and E are the same. इसीलिए फॉर्मूले मेमोराइज करने के लिए पूरा 1 महीना इन्वेस्ट किया मैंने। प्लीज मेमोराइज दिस फॉर्मूले। सो फील्ड डायरेक्टली प्रोपोर्शनल टू द डिस्टेंस आ रहा है कि नहीं?
Yes, sir.
Second question. 3 particles projected vertically upwards from a point on the surface of the earth with velocities this maximum heights attained are. Question क्या डाउट हो सकता है यार? You projected with a velocity of u half mu square minus g capital M small m by r. Maximum height kinetic energy is 0 minus g capital M small m by r plus h. You root over of 2gr by 3 substitute karo, you will get h1. Root over of gr substitute karo, you will get h2. Root over of 4gr by 3 substitute karo, you will get h3. हाँ या ना?
Yes, sir.
Third question is the genuine doubt. This is a hemisphere. थोड़ा ध्यान से सुनिए, बिना सॉल्व किए आंसर बताऊंगा. This is a hemisphere. What is this?
Hemisphere.
Hollow. What hemisphere?
Hollow.
Hollow.
Take any mass. It will be at the same distance from this particular point O, as far as the hemisphere is concerned. Do you
Yes.
agree with that?
Yes,
Yes.
sir.
Yes, sir.
Yes, sir.
So what will be the potential there? dB is minus G dm by R. अब इसे इंटीग्रेट करना है तो माइनस dm by R.
Yes, sir.
Yes, sir.
Now same logic if I take a ring, semicircular ring. अब यहाँ पर जब पोटेंशियल कैलकुलेट कर रहे हो, आप ये एलिमेंट ले रहे हो, ये एलिमेंट ले रहे हो, दिस एलिमेंट, which element you take doesn't matter. It is at the same distance of R. Potential is minus gm by R.
Yes, sir.
What if I fold this side? I will remove the right hand side and I fold it this side. क्या फर्क पड़ेगा? Answer is the same for me. You remove this, every element is at the same distance of R from the point. Answer is the same.
Yes, sir.
Yes, sir.
Suppose if this mass doesn't have uniform distribution, फिर भी कुछ फर्क नहीं पड़ेगा मेरे लिए. यहाँ ज्यादा मास है, यहाँ कम मास है, यहाँ बहुत कम मास है. This is having more mass. Every mass element is at the same distance R. Integral dm will be m, even if it is non-uniformly distributed.
Yes, sir.
आई बात समझ में?
Yes, sir.
I'll have to rub the board. I will not solve the fourth question. Ille.
Answer.
Question number 5. Communication satellite is a geostationary satellite. Communication satellite should be always above the equatorial plane. Time period should be 24 hours and it should be going from west to east. It should be rotating in the direction of Earth's rotation so that the satellite is always above me. See, I am rotating with certain time period. I want the satellite to be above my arm, somewhere here. So the time period of the satellite and mine should be the same, rotating in the same direction. If the satellite is always above my country, I'll be able to use it for communications in my country. That's right.
Yes.
6.
सर बट जो कंट्रीज नॉर्थ पोल या साउथ पोल के क्लोज होते हैं वो कैसे करते हैं?
नॉर्थ पोल साउथ पोल के लिए कम्युनिकेशन सैटेलाइट नहीं होगा भाई साहब. ये जियो स्टेशनरी होना पड़ता है, वो सिर्फ इक्वेटोरियल प्लेन पर ही होगा.
बट वो लोग पोलर सिंक्रोनस सैटेलाइट्स लॉन्च करते हैं ना फिर.
That is for a different purpose. Why should every satellite I launch be a communication satellite? It can be a spy satellite. It can be an ionosphere satellite. It can be measuring launching of Hubble's telescope. Elon Musk will launch only communication satellites because he will make money out of it. There are other countries who will launch satellites for spying.
तो मतलब कम्युनिकेशन सैटेलाइट्स पोलर सिंक्रोनस नहीं होते?
नहीं.
सर तो आपने तो बोला था लाइक यूरोपियन कंट्रीज पुअर कंट्रीज को देते जब वो उसके रेंज में नहीं होता तब.
Yeah, that's why they launch more than one satellite.
तो फिर वो कम्युनिकेशन सैटेलाइट्स है क्या?
Can be. Here their requirement is communication satellite should be a geostationary satellite. It should be at rest with respect to me. With respect to me, it should be at rest. That's possible only in.
Geostationary.
No, they don't get sufficient scope when the countries are above, so they will launch four satellites for different communication time. What he meant in the fifth question is communication satellite implies a geostationary satellite.
Okay, sir, got it.
6. An Earth satellite is moved from one stable circular orbit to another. One stable circular orbit to another larger and stable circular orbit. Following quantities increase for the satellite. Sixth question में among the four options, which point do you have as a doubt?
Sir, D वाला.
Centripetal acceleration. See, you are moving from one circular orbit to another larger orbit here. One circular orbit to another larger orbit. Right? Centripetal acceleration is v square by r. V is root over of gm by r whole square. So gm by r square. If r is increasing, centripetal acceleration is
Decrease. Yes.
So can you explain that?
your voice got cut
Sir,
off. I could
see.
only hear, can you explain the
Can you explain the B option, angular velocity?
B is angular velocity, right?
Yes.
B matlab you are asking angular velocity. You have increased the angular velocity. V is root over of gm by r. R increased, V decreased.
Yes.
V is equal to R omega. Omega is V by R. V is root over of gm by R divided by R. Right? Root over of gm is a constant. R to the power 3 by 2. This is omega. If R increases, will omega decrease or not?
Yes.
Sir, C option.
Linear यार थोड़ा तो दिमाग यूज करो यार. लीनियर वेलोसिटी अभी अभी लिखा यार, बिना सोचे समझे डाउट पूछ लेते हो. लिखा हुआ है बोर्ड पर, v का क्या मतलब? मेरा सरनेम समझ रखा है तुमने? लीनियर स्पीड ही तो है.
सॉरी मैं बस रुका था ये कब खत्म होगा.
लीनियर ऑर्बिटल वेलोसिटी v लिखा है अभी अभी मैंने. अरे भाई साहब, डाउट मतलब मुझे लगा 10 क्वेश्चंस में 5-6 क्वेश्चन डाउट्स. 10 क्वेश्चन में 10 क्वेश्चन डाउट्स पूछ रहे हो आप लोग. हाँ, can I rub the board?
Yes, sir.
Two satellites S1 and S2 of equal masses revolve in the same sense around a heavy planet in coplanar orbit, circular orbit of radius r and 4. अब बोलिए कौन सा बिट कैलकुलेट करो? A, B, C, D में 8%. Eighth question, A, B, C, D में which all bits do you want me to solve? कुछ तो बोलो. Don't tell me all four. Other than that, say something.
जल्दी बोलो। Eighth question किसका डाउट है? T square directly proportional to R cube is my first relation. The ratio of the period of revolutions पूछा है उसने. T1 R1 T2 square 4R whole cube. Agreed. Their velocities are in the ratio. Velocity V1 root over of Gm by R. क्या करवा रहे हो यार? कम से कम which bit पूछ रहा हूँ उसका भी जवाब नहीं दे रहे हो. Orbital velocity का formula डिवाइड करूँ. Eighth में unless you tell me what is your doubt, I cannot help you people here. This is not the way doubt lecture goes. Arbitrarily कुछ numbers बोल दिया, करने दो उसे. Ninth. Time pass कर रहे हो. Satellite, yes, is moving in an elliptical orbit around the Earth. Mass of the satellite is very small compared to the mass of the Earth. Angular momentum, acceleration of S is always directed towards the center of the Earth. Nobody has a doubt in it. 100% acceleration will be towards the center of the Earth, right? Acceleration will be AC. Angular momentum of S about the center of Earth changes its direction, but its magnitude remains constant. Direction भी change नहीं होगा. Angular momentum, satellite is going this way. R cross P, it will be this way. R cross P, direction will always be the same, upwards. R cross P, R cross P, R cross P, R cross P, all throughout R cross P is upwards. So angular momentum, magnitude will remain constant. I'm happy about it, but direction will change is wrong. So B bit is wrong. Total mechanical energy of S varies periodically with time. Total mechanical energy remains constant when it is in the same orbit. Minus 2G minus G capital M small m by 2R. R is the same. When it is in the same orbit, total mechanical energy will remain constant. Same orbit में total mechanical energy is minus G capital M small m by R. R is constant. The masses don't change. Total mechanical energy will remain constant.
Sir, but
Linear momentum remains constant in magnitude. If it is going in an elliptical orbit, linear momentum will not remain constant. क्यों? Linear momentum will not remain constant because velocity keeps changing, speed keeps changing. Elliptical orbit में direction also will change. So linear momentum will not remain constant. Ninth question. Did I answer your doubt? Tenth question. If a satellite's orbit as close to the Earth's surface as possible. If a satellite orbits as close to the Earth's surface as possible.
So C and D में से कौन सा है उसमें डाउट है.
Total energy of Earth plus satellite system is minimum. Use this relation. R is lesser. It is very close to the Earth's surface. मतलब R is lesser. So generally you will think if R is lesser, this quantity is more. But because of the negative sign, R is lesser. You will feel this quantity is larger. Mistake. You have a negative sign in front of it. The quantity will be lesser.
Okay sir.
सर टोटल मैकेनिकल एनर्जी तो सर्कुलर ऑर्बिट्स के लिए कांस्टेंट रहता है ना, ये तो एलिप्टिकल है.
Elliptical में क्यों कांस्टेंट नहीं रहेगा भाई साहब? वेलोसिटी चेंज होगा तो पोटेंशियल एनर्जी भी चेंज होगा. टोटल मैकेनिकल एनर्जी चेंज होने के लिए वर्क डन बाय नॉन कंजर्वेटिव प्लस वर्क डन बाय एक्सटर्नल इज डेल्टा टीएमई. अर्थ एंड सैटेलाइट सिस्टम में एक्सटर्नल वर्क डन डजंट एग्जिस्ट, नॉन कंजर्वेटिव डोंट एग्जिस्ट. क्यों? टोटल मैकेनिकल एनर्जी क्यों कांस्टेंट नहीं रहेगा? इलेक्ट्रिकल ऑर्बिट में जब स्पीड चेंज होता है तो पोटेंशियल एनर्जी भी करस्पॉन्डिंगली चेंज होता है. So that sum total will remain constant. It has to, because work done by non-conservative and external forces is
0.
to take your doubts. I need to have patience. अब हर problem पूछते जा रहे हो. I thought I'll finish off up to exercise 4, but I don't see. Exercise 3 and exercise 4 I will cover day after tomorrow. Tomorrow I mean Dada, right?
Yes, sir.
Yes, sir.
Huh. Then tomorrow evening itself we will clear. Tomorrow evening, 7 o'clock, again in 1 hour, half an hour, we'll finish off exercise 3 and exercise 4. Other than booklet, are there any doubts pending? Old APJC, 2 students first answer this. Other than booklet,
सर HCV में
HCV gravitation,
थोड़ा बहुत बाकी है एंड के
Okay.
क्वेश्चन.
old APJC 3,
No, sir, only booklet is left. बाकी सब हो गया.
okay. The other,
सर
Sir, I think
HCV
HCV is left.
pardon?
HCV is left, sir.
HCV is left. Then listen, tomorrow evening again 7 to 8, we'll take doubts. We'll finish exercise 3 and exercise 4 of the booklet. And some part of HCV at least I will complete. I don't know complete part I'll be able to do or not, depending on the number of doubts you people ask.
Sir, last year IIT JEE वाले भी कर ली.
Those you will have to go through the sources available. Previous JEE questions ka PYQs ka solutions are available at every possible source.
Okay, sir.
Get one, either Arihant or GRB or 40 years old solved papers, which Dadar library mein hai. You're from Dadar or Andheri? 40 years old JEE question papers, हर source में मिलेगा.
Okay, sir.
दादर लाइब्रेरी में है, अंधेरी में भी है.
सर बायजूस की वेबसाइट पे भी मिलता है.
जहां भी previous JEE questions दुनिया भर के sources में available है. Every possible source has got it. Right? So listen. Tomorrow, did I tell anybody else? नहीं, flagship batch नहीं बोला. आप लोगों के लिए ही reserved है. Tomorrow evening 7 o'clock. Is that clear?
Yes, sir.
Sir.
We will finish booklet first. HCV जितना हो सके उतना cover करें.
Okay.
So tomorrow in Dadar, will you take electro doubts?
Did I give you people assignment 1?
Yeah, you
Yes,
gave
sir.
assignment and HCV homework.
Sir, HCV full. Assignment also full.
I have to take. Dadar, last 1 hour I'll take up the doubts tomorrow.
Okay, sir.
Okay, sir.
And so which one will be
Sir.
prioritized?
Pardon?
Which one will be prioritized? Minus the left.
First the homework given was assignment, right? So first assignment covered.
Yes, sir.
So can you do one question?
Bolo.
3 particles, 3 material points of masses m1, m2 and m3 are the vertices of an equilateral triangle of side D. The system is rotating in free space in such a way that under the mutual gravitational interaction of the 3 particles, the system is neither expanding nor contracting. Find angular velocity omega of this rotation. G is
किया ही नहीं यार आज का लेक्चर में किया हुआ है. सो रहे हो आप. 3 particles. This is F, resolve F. 2F cos theta provides the required centripetal force. किया है कि नहीं?
Yes, sir.
So see you people tomorrow evening 7 o'clock. Old APJC 2, old APJC 3 and OD1 Dadar.
Yes, sir. Thank you.
And sir, will you be continuing these doubts online like throughout?
Every week at least 1 or 2 I'll keep.
Yes, sir.
वरना syllabus slow हो जाएगा. आप लोगों को syllabus class momentum should not be disturbed. Doubts we should take it up in the evening.
Sir,
For which you people also will have to
पार्टिसिपेट और rather cooperate यार. 10 क्वेश्चंस में सारे 10 क्वेश्चंस आप डाउट्स बोलोगे तो आई लूज माई पेशेंस. थोड़ा तो आप लोगों को मेहनत करना पड़ेगा.
सर आपके वो प्रीवियस बैचेस हो तो आप उनके डाउट रिकॉर्डिंग्स लाइक सेंड कर सकते हो तो हम लोग मिनिमाइज कर पाएंगे डाउट्स.
कोशिश करूंगा. मुझे भी ढूंढना पड़ेगा, बहुत सारे पड़े हुए हैं. मुझे भी ढूंढना पड़ेगा.
सर आप मत ढूंढो ना सर, आपके इतने मेटिकुलस स्टूडेंट्स हैं उनसे मांगो ना सर.
अब ट्राई करूंगा.
क्योंकि सर हर एक बैच में एक ना एक ऐसा बंदा होता ही है जो प्लेलिस्ट बनाता है.
लेट मी सी, लेट मी ट्राई. ओके
ओके सर.
चलो बाय, गुड नाइट.
Bye, sir.
Bye, sir.